What's up, everyone? This is LeetCode 53, Maximum Subarray. We're finally getting to the medium problems, no more easies. We've done all the easies so far in the Grind 75 list, so congrats if you've been following along. So anyways, let's get into the problem. So we're given an integer array nums, find the subarray with the largest sum and return its sum. A subarray is a contiguous, non-empty sequence of elements within an array, right? Pretty simple, right? It's a sequence of elements that's non-empty and it's contiguous. So there's many possible subarrays for our input, right? And we need to find which one gives us the maximum sum. And obviously the tricky part is some of these numbers are negative, right? And so how do we find the maximum sum here? And really the trick is that we want to keep track. We're going to go through this array, okay, linearly. And as we go along, we need to keep track of the current sum as we add these numbers up. And we need to keep track of the maximum sum we've seen so far. And the reason is because let's say we take this for this subarray here. The maximum sum we've seen so far is -1, right? Well, what if we take this subarray here? Well, the maximum sum would be 2, right? So we'd have to update max sum. But when we're calculating the sum to check if it's greater than the max sum, right? The sum of these two numbers is different than the sum of these numbers, which is why the current sum is going to change over time, but the maximum sum may or may not change. Depends if we find a number that's greater than the max sum, right? So the way we're going to do this, right, is obviously we have to, as we establish, we're going to have a current sum and a max sum, okay? Now, the max sum initially, right, we don't know what it's going to be. So we're going to set that to -infinity, right? Right. And we will update this at some point. And we're going to have a current sum, okay? And again, like I said, we're going to go through this linearly, right? So we're going to say for num in nums, right? And basically, we're going through this linearly, right? So let's, as we're going along, right, we're going to add num, whatever num is, to the current sum, okay? And then we're going to check if the current sum so far is greater than the max sum, right? So we're going to say max sum, current sum, right? And let's just go through an example 1, right? Max sum initially is -infinity. Okay, current sum, add num, which is -2. -2 is greater than -infinity, so -2 would be our new max sum as we're going along. Okay, makes sense. Now we go to 1. We add 1, and we have -1. But, you know, here's the problem. Why would we want to take -1 in this case instead of just taking 1, which is bigger, right? So the way to avoid this is if we have a current sum that is negative, why don't we just set it to 0? Because if we have a positive number, that's always going to be greater than any current sum that's negative, right? If we have an individual number that's positive, that will always be greater than any sum of numbers if the sum is negative, right? So we can just say if the current sum is less than 0, we can just set the current sum to 0. Okay? And again, at the end, we need to return the max sum. Okay, so let's go through this example. We add -2, right? Because num is -2 as we're going through the for loop. Okay. We're comparing a -infinity to -2. Okay, so -2 gets updated, right? That's a bigger number. Okay. The current sum is negative right now, so let's set it to 0 and move on to the next number, which is 1. Okay, well, 1 is greater than -2, so 1 is our new max sum. Okay. Go on to the next step, we add a -3, so we have -2. We don't update max sum because -2 is not greater than 1. And let me just do this in a comment, right? Keep track as I'm going through this example. So the max sum so far is -1. The current sum, again, we have 1 and -3, which is -2. But again, that's less than 0, so let's set this to 0. Okay, move on to this next one, which is a 4. right? Current sum plus num, which is 4. So our current sum is 4. Okay. Is 4 greater than 1? Yes. So 4 is our new max sum. Right? Okay. Move on to the next one. Okay, -3. -3 is not greater than 4. Move on. Or not -3, sorry. 3 is not greater than 4. Okay, now we add 2. So we have, sorry. We add 4 plus -1, so our current sum is 3. Now we add 2, which is what, 5? Okay, 5 is greater than 4, so let's update our max sum. Okay, move on to the next one. Oh, we have 6. Okay, because we added 1, right? Or sorry, this max sum initially is 5. Now we update it to 6, though. Getting a little bit ahead of myself. Okay, and then we add -5. So 6 plus -5, that's just 1. And again, then we do 4. And that would be what? 5. But that is not greater than the max sum, so that never gets updated. So again, right, this would be the max sum, right? This sequence of digits, or this subarray, which is a contiguous non-empty sequence of elements. And max sum should be 6, right? So when we return here, we should get the expected output, which is 6. So that's good. I'm not going to go through example 2. That's a bit silly. It's just one element. Let's go this example, okay? We add 5 to the current sum. Okay, set that as our new max sum. Then we add 4, so we have 9. Update our max sum, right? Then we add -1. That would be what? 8. That's not greater than the max sum. Then we add 7, right? Which is 15. So we add our max sum increase. Then 15, right, plus 8 is 23, right? So when we add 15 and we add 8, we get 23, right? So we have to update our max sum and our current sum. Well, we would update our current sum first, then our max sum, right? Because 15 plus 8 is 23. And so basically this entire subarray, which is just the entire array itself, is the largest sum. Pretty simple. Now let me give you a very interesting also test case, right? Let's say we have a bunch of negative numbers like -2. Let's say -5, -2, -7. Something like that, okay? Let's go through this. So if current sum, let's go through current sum, right? That'd be -5. Okay. And again, max sum is initially -infinity. So when we take the max between -infinity and -5, -5 is bigger than -infinity. So -5 would be our new max sum. And again, current sum would be negative, right? So we would set current sum to 0. Move on to the next one, -2. Well, when we compare -5 and -2, -2 is actually bigger than -5, right? So this would be our new max sum. And again, we set it back to 0, right? Current sum would go to -7, and -7 is not bigger than -2, so we would return -2, which is what we should expect. Because if we have an integer array, right, that is -5, -2, and -7, right? This is the largest subarray. Okay, so that's kind of how we're doing this problem. I believe this specific algorithm is called Kadane's algorithm, right? Formally is called Kadane's algorithm. But yeah, hopefully I explained that well. I just went through the examples. Makes this video a little bit longer, but if I go through the examples, it's very easy to understand what we're doing, okay? So yeah, this is our first medium problem on the Grind 75 journey, and I hope this helped. And I'll see you in the next one.